We are Team 12302, G-P Robotics Synergy, and this is our Control Award submission video. In order to pull off our autonomous, we use motor encoders in the internal measurement unit, or IMU. The motor encoders are used to track the robot's position on the field and is used to create an optimized path called splines, as seen here. We can enter in a bunch of coordinates the robot needs to go to then have the robot follow a curved path. This, as well as an acceleration program, prevents the most wheel slippage, guaranteeing a reliable autonomous. The IMU will give the angle of the robot, which is used for an angle correction algorithm. Both the motor encoders and IMU are incredibly important for our driver control portion, as we can combine them to find where the robot is on the field. This allows us to calculate the needed velocity and rotation for the robot in order to shoot reliably in the top goal from anywhere. We have a few other smaller sensors on the robot as well. On the right side of the robot we have two distance sensors, on the bottom we have a color sensor, and on the left side is two more distance sensors. We use the distance sensors to detect the number of rings on the field to put the wobble goal at the corresponding square, which has been deemed to be more confident and time efficient in its predictions than TensorFlow. The color sensor is used when running over the white tape to detect it and reset the robot's alignment in case the motor encoder positions lose value over time. For drivers, we have set up a system that allows multiple functions while being easy to understand during an intense competition. For driver 1, the movement is mapped on the joysticks, with the triggers allowing different speed controls. The A button makes the arm grab the wobble goal, and the X, Y, and B buttons move the arm to set positions. The bumpers control the side servos, which allows to stop any rings that pass for easy access. For driver 2, the left stick controls the intake. The Y button activates the shooter, which again calls the calculated rotation and velocity to be applied to the robot. The X, A, and B buttons change the position of the target for the shooter to align with the power shots, with the D-pad allowing for shooter calibration to adjust for any position misalignments. Finally, pressing the right trigger activates the kicker to shoot out rings. This all comes together to allow our robot to work at its fullest. If you wish to learn more about any features talked about in this video, feel free to reach out to us on our YouTube channel, G-P Robotics.